Good evening, and welcome to Dream Theatre for a relaxed mind. Turn out the lights and put on the kettle. Coffee, tea, or perhaps something even more ambitious. Tea and Gravity, a little corner of the universe where we let science take off its lab coat, put on its fluffiest dressing gown, and make itself a warm cup of something soothing. I'm Professor Teabottom, former astrophysicist, current tea enthusiast and biscuit philosopher. Before we tumble headlong into tonight's sleepy tale of science and softly simmering wonder, a small request from your ever-thirsty host. If you find yourself enjoying these curious bedtime ramblings, do please like this video and subscribe to the channel. And if you've a moment more, consider joining our free Substack. There you'll be notified the moment a new episode appears, and you'll gain entry to a rather cosy salon of discussion, where we share thoughts, swap ideas for future episodes, and occasionally argue politely about whether gravity has a favourite biscuit. The link's tucked in the description like a note under a teacup. Now then, let's begin. Quantum entanglement, or why the universe is slightly clingy. With me tonight is Pig, the orange and white sage who has mastered the mysteries of the universe, or, at the very least, those of a well-heated cushion. As always, the ever-elusive Jupiter and Jupiter are around here somewhere, or perhaps entangled with some far-flung dust bunny beneath the old upright piano. Outside, the Sussex rain taps gently at the leaded windows, a soothing percussion that always reminds me of Alan Parsons doing sound checks with a box of spoons. The study is warm, the fire a soft golden glow in the grate, and Pig, for once, is contentedly snoozing by the hearth. He purrs occasionally, a deep rumbly sound that seems to rattle the iron fireguard and unsettle the dust on the mantelpiece. There's something especially right about nights like these, when the world is quietly busy washing itself, and you're safely indoors with a mug of tonight's chosen blend, Entanglement Earl Grey, which, according to the label, pairs best with uncertainty. Now, speaking of uncertainty, tonight's subject is quantum entanglement, the strange, not entirely polite way that the universe insists on keeping things connected, even when they're much too far apart for comfort. Quantum entanglement is, at its heart, a cosmic tendency toward clinginess, a sort of existential group hug enforced upon particles whether they like it or not. To begin, let us consider an experiment both scientific and, dare I say, quintessentially British, making tea for two. Imagine, if you will, two teacups, one with a chip from a youthful misadventure at Brands Hatch, the other bearing the faded crest of an Oxford college I only attended by accident. I pour from the same teapot, the fragrant steam curling upward in delicate spirals, one for each cup, identical in aroma and intention. Now here's where the quantum mischief begins. Suppose, as I set out the sugar bowl, I notice something peculiar. Every time I stir one cup, the other ripples, as if compelled by sympathy or secret communication. Drop a biscuit in one, and the other mysteriously grows soggy too. It's as though the cups have entered into some unspoken pact. No matter how far apart I set them, one seems to know what's happening to the other. Ridiculous, you say? Nonsense, which incidentally is where quantum physics truly shines. Quantum entanglement, in the world of the very, very small, is just such a scenario. Two particles, electrons, photons, or what have you, prepared together in such a way that their states, spin, polarization, T-preference, are linked regardless of distance. Change something about one, and the other feels it instantaneously, even if they are on opposite ends of the universe. Einstein, who never could abide a sticky mess, called this spooky action at a distance, and was famously unamused. But let's not get ahead of ourselves. Before the mathematics and the metaphysics, before the experimentalists in their white coats and questionable haircuts, there was simply the observation that some things in this universe refuse to act alone. Entanglement is, in its most poetic sense, the universe's reminder that nothing exists in perfect isolation, that to measure, to stir, to observe one thing is always, inevitably, to nudge something else. Pig, who has spent a lifetime proving that observation alone can alter the state of a roast chicken sandwich, would no doubt agree. There's a look cats have, a narrowing of the eyes, a flick of the tail, that seems to say, you think you're alone, but I assure you, you are being watched by forces both seen and unseen. If Pig had access to a particle accelerator, and given his resourcefulness, it's only a matter of time. I imagine he'd find the entire enterprise familiar. After all, what is entanglement but a very technical excuse for being inextricably linked to someone else's business? Returning to our tea, the two cups, though separated by the length of the kitchen, the width of the channel, or the breadth of the observable cosmos, remain, in some mysterious mathematical way, a single system. If I should decide on a whim to sweeten my cup with 2 lumps of sugar, the other cup unbidden registers the change. Not literally, of course. There is no physical channel, no message sent, no rogue sugar cube tunnelling across the room. And yet, at the quantum level, such eerie correspondences are not only permitted, but in fact required. It's a scenario so odd, so deeply counterintuitive, that for years most physicists dismissed it as a peculiarity of mathematics, one of those theoretical flights of fancy best left to poets and madmen. But the universe, as it so often does, had the last laugh. As the fire crackles and Pig stirs, I'm reminded of a line from my old friend Richard Feynman. If you think you understand quantum mechanics, you don't understand quantum mechanics. Which is to say, don't fret if you find your mind wandering or your logic doing backflips. Entanglement is, at best, something to be approached with an open mind and a willingness to accept that some teapots are best left inexplicably connected. So as you sip your tea, entangled or otherwise, ponder the possibility that somewhere out there, another cup, another listener perhaps, raises their mug in a toast to cosmic togetherness. We are, in the end, all part of the same strange sticky universe, bound by threads we cannot see, but which tug at us all the same, and thus, with Pig purring and rain pattering and uncertainty swirling in the pot, we are ready to venture further into the peculiar world of quantum entanglement. Refill your cup, settle in, and prepare, if not for understanding, then at least for wonder. Spooky action at a distance. Now, before we go any further, it would be positively criminal not to address one of the most deliciously scandalous phrases in all of physics. Spooky action at a distance. If you've never heard it spoken aloud in a smoky pub by a Nobel laureate, you've missed one of life's finer pleasures. The phrase, you see, was coined, somewhat begrudgingly, by none other than Albert Einstein himself. And if you can imagine a man with more gravitas than Einstein, you've clearly never watched Pig attempting to claim the last sardine on a rainy Thursday. Picture, if you will, Einstein sitting in his study. Woolly hair askew, chalk dust drifting like tiny galaxies through the lamplight, a pipe threatening to fall from his lower lip. He's muttering in German, but the gist of it, translated into polite Sussex English, is something like, "Oh, come on, the universe simply doesn't work this way. It's indecent." Spooky action indeed. Einstein found quantum entanglement profoundly unsettling. To him, the notion that two particles could remain connected, such that a measurement on one would instantly affect the other, regardless of the chasm of space between them, was not only counterintuitive, it was deeply unseemly, as if the universe had thrown etiquette to the wind. It was, in Einstein's words, spukhafte Fernwirkung, spooky action at distance. I suspect he rather hoped the phrase would frighten the idea back into the shadows. But as is often the case with both ghosts and quantum mechanics, the spookiness persisted. Now, I'm not one to contradict the great man himself, especially given that my cousin George once chauffeured him to a particularly memorable Princeton luncheon. But even Einstein, for all his brilliance, was capable of being caught off guard. You see, entanglement is one of those scientific concepts that seems determined to act like an ill-behaved child at a tea party, making a scene just when you think all is calm. To illustrate, allow me a playful anecdote. Imagine the first scientist who stumbled upon quantum entanglement, innocently performing an experiment in a drafty laboratory, probably somewhere with leaky pipes and a persistent smell of boiled cabbage. Perhaps she was observing two particles born together in the same reaction, like a pair of siblings, forever linked by origin, yet fated to go their separate ways. She measures the spin of one particle, let's call it lefty, and to her astonishment, the other particle, righty, immediately reveals the opposite spin, even if it's clear on the other side of the laboratory, or indeed the solar system. This peculiar relationship between particles is not unlike the bond between siblings who, despite being continents apart, somehow manage to finish each other's sentences over the phone, or sense when the other has run out of biscuits. In fact, there's a family legend that my own twin great-aunts Rose and Lily once invented synchronized sneezing, much to the confusion of the local physician. Perhaps quantum entanglement is simply the universe's way of keeping familial mischief alive at the subatomic level. Now, Pig, who is eyeing me suspiciously from the hearth, would have you know that cats too are experts in spooky action, though their version involves appearing behind you precisely when you open a tin of tuna, no matter the room, the floor, or the locked door between you. If physicists had chosen to study cats rather than particles, I suspect the mysteries of entanglement would have been solved, and then promptly ignored, in favour of a nap. Einstein, for all his scepticism, was not alone in his discomfort. The idea of spooky action at a distance sent shivers through the scientific community. Even Niels Bohr, Einstein's old sparring partner and master of the quantum cryptic crossword, admitted that entanglement defied common sense. In those days, to suggest that information could travel instantaneously, faster than light even, was to risk polite laughter at your expense or worse, a stern letter from the Royal Society. And yet the experiments piled up, like teacups after a particularly talkative afternoon. Each new study confirmed what the equations predicted. Particles separated by impossible distances really did behave as a single, unified system. To measure one was, in a very real sense, to touch the other, no matter how far away it might be. It was as though the universe itself were whispering, "You can have it all, but how much do you want it?" Thank you, Oasis. Even in quantum physics, the classics endure. To the layperson, and frankly to most of us in the trade, this sounds like sheer fantasy. It's tempting to imagine a secret tunnel, or perhaps a clever postman ferrying news between the particles, but there is no tunnel, no messenger, no Wi-Fi. There is only the simple, implacable fact that the two particles, having once shared a moment of creation, are now forever linked. Pig, meanwhile, is now twitching in his sleep, perhaps chasing entangled mice across the rug of space-time. He has no patience for debates about locality or hidden variables. He is content to accept that some things are simply so, and that the world is all the richer for its mysteries. For Einstein, however, the mystery was an itch he couldn't scratch. He was fond of saying, "God does not play dice with the universe." Bohr, with typical Danish mischief, would reply, "Einstein, stop telling God what to do." Their debates, half philosophy, half slapstick, became the stuff of legend. I've often imagined them at tea, Einstein quietly fretting over the cutlery while Bohr sneaks extra sugar into the pot. So the next time you notice something inexplicable, a friend who calls just as you think of them, a biscuit that vanishes the moment you look away, or a cat who appears precisely where she ought not, remember that the universe too delights in a bit of spooky action at a distance, as the rain thickens against the window and Pig rolls over, exposing a scandalous amount of belly. I am reminded that even in a world ruled by logic and measurement, there remains room for the uncanny, the improbable, and the delightfully spooky. In quantum entanglement, the universe winks at us, reminding us that everything is, in some mysterious way, connected. With a fresh cup of entanglement Earl Grey in hand, I invite you to lean a little closer to the fire and prepare yourself for the next chapter, where great minds argue, biscuits are broken, and the peculiar dance of quantum connection continues. Pig, for his part, has already claimed my favourite chair. Typical. Einstein's scepticism and Bohr's confidence. If you ask me, the best way to understand the history of science is to imagine it as an endless tea party, one in which the biscuits never quite last as long as the arguments, and where, somewhere between the sugar bowl and the lemon slices, the nature of reality is thrashed out with all the civility that can be mustered by people who haven't slept since Tuesday. Quantum mechanics, with its paradoxes and peculiarities, has had more than its share of these parties, but none more spirited than the ongoing intellectual duel between Albert Einstein and Niels Bohr. If the annals of physics were a gentle soap opera, Einstein and Bohr would be its leading characters, one a stoic, wild-haired visionary with an allergy to nonsense, the other a genial, smiling Dane whose confidence in the bizarre bordered on mischievous. Picture, if you will, a smoky hotel lounge in Brussels in the late 1920s, all heavy drapes and starched tablecloths. It is the 5th Solvay Conference, a summit of the greatest minds in physics. Einstein and Bohr are locked in debate at a round table in the corner, cups of rapidly cooling tea forgotten in their hands. Other physicists orbit the pair, hoping for a moment of insight or perhaps a biscuit. Pig, in the manner of all good cats, is not present, though I'm convinced were he alive in that era, he'd have found his way into Bohr's lap, purring contemplatively, while Einstein gestured at the ceiling. You see, Einstein was deeply unsettled by what quantum mechanics seemed to imply about the universe. Probability, chance, indeterminacy, these were words that left a bad taste in his mouth, like an Earl Grey steeped far too long. God does not play dice with the universe, he famously declared, fixing Bohr with a stare that had made lesser men spill their tea. Bohr, however, had an unflappable faith in the mathematics, and in the universe's penchant for the unexpected. He saw no problem in dice-throwing gods, so long as the equations worked out in the end. His favourite retort, Einstein, stop telling God what to do, became a kind of running joke among their colleagues. If you listen closely on a rainy night, you can almost hear their ghostly laughter echoing down the corridors of physics departments worldwide. Their debates were legendary, not because one won, but because each brought the other's thinking to its sharpest edge. Einstein, ever the skeptic, devised a series of thought experiments meant to expose quantum theory's supposed absurdities. Bohr, with infinite patience and no small appetite for biscuits, parried everyone with ingenious arguments and occasionally a sly grin. Some evenings, the only casualties were the teacups which bore the scars of 100 refills and more than a few impassioned gesticulations. It's important to remember that for all their disagreement, these two giants were also friends, in the peculiar way that only brilliant rivals can be. There's a warmth in their correspondence, equal parts admiration and exasperation that feels, to me, rather like the best sort of family squabble. I imagine them sharing a silent moment after the last of the guests had drifted away, watching the dregs swirl in their cups and wondering, not for the first time, whether the universe was laughing at them both. Let me offer a tale of my own, a much humbler echo of those grand debates. Years ago, in the days when I was still learning the fine art of scientific disagreement, I found myself locked in a heated argument with an old friend over the precise temperature at which scones should be baked. He insisted on a hot, quick blast. Shock the dough, Teabottom, while I favoured a gentler, slower approach, so the butter has time to consider its options. The argument stretched on for hours, scones growing colder by the minute, until Pig, sensing an impasse, solved the matter by knocking both trays to the floor and devouring the lot. That some arguments are best left unresolved, and that cats are the only true arbiters of domestic science. But back to Einstein and Bohr, and the heart of their disagreement, entanglement. Einstein could not accept a universe where cause and effect might be uncoupled, where particles could affect one another instantaneously, without any physical connection. To him, it was as if the world had abandoned its own rules in favour of magic tricks and sleight of hand. He called this non-locality, and spent years searching for a way to prove that quantum mechanics, while useful, was incomplete. A brilliant but ultimately flawed theory that hid a deeper, more rational order. Bohr, meanwhile, was serenely confident that the universe was exactly as strange as it appeared. There is no quantum world, he once remarked. There is only an abstract quantum physical description. In other words, don't worry about how it works, just trust the math and pass the biscuits. Their exchanges became increasingly elaborate, each devising ever more cunning thought experiments. One of Einstein's favourites, the EPR paradox, named for Einstein, Podolsky and Rosen, asked, if you measure the state of one particle, how does the other, separated by light years, instantly know what to do? Surely, he argued, there must be some hidden information, some local variable must pass between them. Bohr, never one to shy from a puzzle, responded with the kind of philosophical jujitsu that left entire generations of physicists scratching their heads and reaching for the teapot. These debates didn't end with a clear winner. In fact, they lingered for decades, growing richer with each new experiment and each fresh generation of physicists. Like the best conversations, they left more questions than answers, a tradition I'm proud to uphold here in the study, where every cup of tea is an invitation to wonder. Pig, meanwhile, has emerged from his nap and is now performing an elaborate full-body stretch, tail aloft and whiskers twitching. I suspect he's making his own philosophical statement, namely that the universe is best contemplated on a full stomach, in front of a warm fire, and with as little fuss as possible. There's a lesson there somewhere. If you take nothing else from the tale of Einstein and Bohr, let it be this. True intellectual disagreement is not about victory, but about mutual transformation. Each, in challenging the other, deepened his own understanding, and, by extension, ours. there is a beautiful humility in admitting that we may never settle the matter, but that the pursuit itself is a kind of triumph. As the rain softens and Pig settles in my lap, I am reminded of the countless evenings spent debating, dreaming and disagreeing, with friends, with history, even occasionally with the contents of my own kitchen. Science is not a march toward certainty, but a meandering stroll through mystery, accompanied by the best minds you can gather and the occasional cat. So, the next time you find yourself locked in a gentle argument, whether over quantum mechanics or the best way to brew a pot of tea, remember Einstein and Bohr, forever circling the truth, forever friends, and forever entangled in the beautiful uncertainty of not quite knowing. In our next part, we shall step further into the woods, following the trail Einstein and Bohr blazed, and ask, could anything finally convince even the greatest skeptic that the universe is, at heart, a bit of a meddler? Bell's theorem awaits us with biscuits, hopefully in hand. Bell's inequality, proving the universe is clingy. There's an old saying in science, well, old by the standards of scientists who live on caffeine and deadlines, that goes, extraordinary claims require extraordinary evidence. And so, for decades after the spirited debates of Einstein and Bohr, the world of physics was haunted by a most extraordinary claim, that particles could be so entangled, so perfectly clingy, that no matter how you separated them, they'd forever behave as if they were sharing a secret. Many physicists, content with theory but hungry for proof, quietly hoped someone would devise a test, a kind of ultimate biscuit dunk to settle the matter. Enter John Bell, a quiet genius from Northern Ireland, who preferred clear logic and black tea to the wilder flights of philosophical fancy. Bell was the sort of man who could explain the quantum universe with the patience of a vicar teaching chess to an eager but distractible choir boy, or indeed a distracted cat. Now Bell looked at the mess of equations and said in effect, let's see what the universe does when we're not looking. Let's set a trap for these particles and see if they really are as inseparable as the maths suggest. He crafted what became known as Bell's inequality, a test so elegant, so diabolically clever, that it made even the most seasoned theorists sit up straighter at their desks. The essence of Bell's idea is this. If particles have hidden instructions, secret notes passed between them at the moment of their creation, then, with careful experiments, you should find telltale fingerprints, evidence of an ordinary non-spooky connection. But if, on the other hand, the universe truly is as clingy as quantum mechanics predicts, then no such fingerprints will appear, only the unmistakable trace of instant, inexplicable connection. This brings me rather inevitably to Twinkies. You see, when I was a young man, newly arrived in America for a rather disastrous conference on theoretical acoustics, I was introduced to the venerable Twinkie by an American colleague, a man with a profound love for improbable snacks. He declared that the true joy of the Twinkie is not in eating it alone, but in the inevitable moment when, having purchased a pair, you discover that they're stuck together inside the cellophane. No matter how carefully you try to peel them apart, a bit of filling is always left behind, transferred, as if by quantum mandate, from one cake to the other. The Twinkie, I realised, is a perfect metaphor for Bell's great experiment. Imagine, if you will, two Twinkies, born together, packaged side by side. Separate them as carefully as you like, and yet a bit of one is always found clinging to the other, a tiny sugary echo of their shared origin. You can run your tests, inspect the wrappers, but the evidence remains. These cakes, for all appearances now distinct, are forever marked by their entanglement. So it was with Bell's experiment. When the tests were finally performed, years later, the results were clear, and deeply unsettling to anyone hoping for a more polite universe. The particles, even when separated by enormous distances, refused to act independently. Their behaviour could not be explained by any hidden signal or classical trickery. It was, quite simply, as if the universe had declared, yes, things really are that weird, kindly pass the Twinkies. The confirmation of quantum entanglement was both thrilling and unnerving. Suddenly every physicist in the land had to contend with the reality that the world is not a collection of isolated objects, but a tangled web of relationships, a cosmic game of Twinkie tag, if you will, in which every particle remembers its partner. Pig, who has now managed to unearth a crumb of something long forgotten from beneath the armchair, seems entirely unsurprised by this turn of events. Cats, after all, have always known that the important things in life are the connections you make. the link between a paw and a sunbeam, a whisker and a passing draught, a pair of eyes, and the unwavering trajectory of a roast chicken. Pig's understanding of entanglement is instinctive, practical, and completely uninterested in mathematical proof. As I reflect on Belle's achievement, I'm reminded of a particular afternoon in my own kitchen, attempting to separate a stack of scones that had, through a mixture of overzealous enthusiasm and underwhelming flour, fused together in the oven. No matter how I pried and sliced, a fragment of one always clung to the next, a carbohydrate echo of their shared beginning. My guests, British Stoics all, simply shrugged and declared, "It's all going to the same place, Professor." I suspect Belle would have agreed. The implications of Belle's theorem were, and remain, profound. No longer could we comfort ourselves with the notion that the universe was made up of perfectly independent bits, going about their business in splendid isolation. Instead, we must accept that, at the deepest level, the world is stitched together by invisible threads, connections that defy both distance and common sense. It is a humbling thought, and a beautiful one. We are, each of us, a bit like the Twinkies in their wrapper, seemingly separate, yet always, inevitably, leaving a part of ourselves with others. Science, for all its rigour and scepticism, occasionally finds itself stumbling into poetry. Pig has now decided to test Belle's theorem personally, attempting to separate two cushions on the settee, only to find that no force in this universe, short of a determined nap, can keep them apart. He gives me a look that says, "I told you so," before settling in for another well-earned rest. And so, as rain continues its gentle assault on the window pane and the fire flickers lower, I find myself strangely comforted by the clinginess of the universe. It is, after all, what makes the world interesting, what ensures that no matter how far we travel, some part of us is always left behind, waiting to be discovered in the company of others. In our next part, we shall confront a question that haunted Einstein and delights Pig. Does all this cosmic togetherness mean that something, information, love, or the occasional sardine, can travel faster than the speed of light? Or does the universe have even more tricks up its sleeve? Stay tuned, dear listener, and keep a Twinkie handy. You never know when a metaphor might come in useful. Faster than light. Hold your teacups. After Belle's theorem crashed through the polite barriers of common sense, physicists the world over found themselves in an unfamiliar predicament, like musicians handed instruments, but told the notes might come before the melody. Suddenly the old cosmic order was wobbling. If entanglement meant that a measurement here could instantly affect a partner particle over there, could something, some information, perhaps, travel faster than light? Was Einstein, that great traffic cop of the cosmos, due for retirement? And, most pressing of all, could this discovery be used to get tea delivered more quickly on a rainy evening? Let's not rush to the edge of the speed limit just yet. The idea of something moving faster than light is the scientific equivalent of a cat at a wedding. It's disruptive, memorable, and bound to leave fur everywhere. Einstein's special relativity declared with absolute certainty, nothing, absolutely nothing, goes faster than light. It was as much a matter of principle as it was of physics. If information could outpace light, causality itself, this thing follows that tea before biscuit would unravel, and we'd be left in a universe as chaotic as Pig's old toy box. Pig, for his part, is at the window now, watching the droplets trace bright zigzag paths down the glass. His tail flicks rhythmically. Every now and then, he casts a glance my way, as if pondering whether he, in a fit of feline ingenuity, might one day break the speed of light. It seems unlikely, given that he refuses to exceed 4 miles per hour, unless chased by the vacuum cleaner. But if ever there were a cat to crack the secret, it would be Pig. Let's indulge for a moment in a little thought experiment, a specialty of physicists and insomniacs alike. Suppose I prepare 2 saucers of milk, entangle them through some quantum culinary trickery, and set them at opposite ends of the study. If I add a drop of honey to one, will the other instantly taste sweet, regardless of the space between? If so, could I, with enough practice and a large enough house, set up an instantaneous tea service between Sussex and, say, Tokyo? Alas, as I'm sure you suspected, the universe has a habit of thwarting such schemes. Entanglement, for all its apparent spooky action, is not a cheat code for breaking the speed limit. It's not a tunnel, nor a telephone, nor even a very efficient carrier pigeon. The results of a measurement on one particle are correlated with those of the other, yes. But there's no way to use this fact to transmit a message, or a scone, or even an earnest request for more cream faster than light. Here's the trick. When you measure one entangled particle, its state collapses into a definite value, say, spin up. Instantly, its twin, wherever it may be, is guaranteed to be found spin down. But, and here's the crucial bit, neither you nor your distant colleague could predict which way the particles would land until the measurement is made. There's no code, no Morse, no secret handshake. You can't send, help, Pig has knocked over the milk again via quantum entanglement any more than you can organise your socks by shouting at the drawer. It's as if the universe, in its infinite wisdom, listened to Einstein's worries and then decided to split the difference. Yes, everything is connected, but no, you may not use this fact to cheat on your physics homework. In other words, we all want to change the world, but when you talk about destruction, don't you know that you can count me out? Thank you, Beatles. Revolution provides the perfect footnote to quantum mischief. Pig, apparently satisfied with this explanation, has abandoned his window post in favour of the armchair, where he now sits in a pose of perfect feline contemplation, one paw draped over the side like a loungewear model in a glossy magazine. He looks every inch the seasoned quantum theorist, equal parts boredom and gravitas. Let's get practical for a moment. If entanglement can't send messages faster than light, what, then, is all the fuss about? Why did Einstein fret, and why do physicists still fill entire journals, and many a coffee shop, with diagrams of particles, squiggly arrows, and the occasional desperate doodle of a spaceship? The heart of the matter is the nature of information and causality. If you could use entanglement to send information instantaneously, the entire structure of cause and effect would be at risk. You could, in principle, send a message into the past, tell yourself not to eat that third slice of cake, or to invest in a company called Apple before it meant anything other than fruit. The paradoxes multiply, and soon you're adrift in a sea of what-ifs and self-negating time loops. As any cat will tell you, chasing your own tail is fun but rarely productive. What entanglement gives us, then, is not a way to send signals faster than light, but rather a profound reminder that the world is more interwoven than it appears. The connections are real, but the communication, at least in the way we usually think about it, remains bound by the universe's old, reliable speed limit. There's something comforting about that, I think. It means that, even as the universe grows ever stranger, there remains a thread of order, a cosmic etiquette as reliable as the rule that tea is always better shared. Of course, this hasn't stopped generations of clever minds from dreaming up ways to outsmart the cosmos. Quantum teleportation, quantum cryptography, quantum everything, each a tantalizing attempt to turn the rules to our advantage, and each so far politely but firmly rebuffed by the laws of physics. Sometimes I suspect the universe enjoys our attempts, the way a chess grandmaster smiles at the bold, doomed moves of an enthusiastic novice. Now you may be wondering, what does Pig make of all this? In the spirit of empirical investigation, I once attempted a small experiment. I placed two identical cushions on opposite sides of the study, both freshly plumped and dusted with just a hint of catnip. Pig investigated the first, kneading it with a critical paw. At that very moment, Jupiter, the more present of the two absent cats, wandered in from the hallway, sniffed the second cushion, and immediately curled up for a nap. Coincidence? Entanglement? Or simply the mysterious synchrony of cats? I'll leave that to future generations of physicists, and perhaps cat therapists. There's a strange joy in these cosmic limitations, I find. Knowing that the universe is both more connected and more reserved than we expected means there's always another mystery to chase, another boundary to test, another reason to pour one more cup of tea and speculate long after the fire has died down. It's the spirit of discovery, the delight in what we cannot yet do, and the hope that one day, perhaps, Pig or someone equally improbable will find a loophole. Outside, the rain has picked up, drumming more insistently against the glass. The study is thick with shadows and the scent of overbrewed Earl Grey. Pig, now snoring, offers the occasional twitch, as if dreaming of a chase through dimensions, tail streaming behind him at precisely 299,792,458 metres per second, the universal speed limit, give or take a whisker. As I refill my cup and nudge Pig's paw off my notes, I'm reminded, not for the first time, that the best stories, like the best physics, are those that invite us to peer over the edge without quite tumbling in. There's a song in the world, a pulse, a rhythm you can feel in your bones. Nothing's going to change my world. Across the universe. The Beatles again, always sneaking into the heart of things, just as quantum entanglement sneaks into the fabric of reality, subtle but profound. So, dear listener, as we sit together on this rainy night, let's be grateful that some things, at least, stay anchored even as everything else grows strange. The speed of light remains the universe's reliable referee, keeping causality safe, stories coherent, and, perhaps most importantly, giving us all just enough time to savour a proper cup of tea. In our next chapter, we'll leave the speed limit behind and wade into the truly mind-boggling quantum experiments where logic seems to vanish and the universe dances to its own eccentric tune. For now, though, I'll let Pig dream of racing light, and I'll raise my cup to the mysterious, marvellous order of it all. Quantum experiments that defy common sense. There comes a moment, on the path through quantum mechanics, when even the most resolute rationalist must set down their mug and admit the universe is having a bit of fun at our expense. Bell's theorem had already upended the tea table of reason, but what followed? Well, it was as if the crockery itself began to hover mid-air, spinning gently, refusing to obey the laws of gravity, taste, or common sense. It was the age of the great quantum experiments, brave souls in white coats and rumpled jumpers, peering through microscopes and muttering about photons, polarization, and the peculiar tendency of reality to slip out the back door whenever you thought you'd finally pinned it down. They devised tests so delicate, so fiendishly clever, that even Einstein's ghost, had he been present, and I see no reason to think he wasn't, he always did enjoy a good argument, would have paced anxiously around the apparatus, grumbling about the decline of proper scientific standards. But let's leave the lab for a moment, and return to a scene more familiar. My study, on a night like this, rain tap dancing against the windows, Pig curled in front of the hearth, the fire casting gentle shadows that flicker like the after-images of forgotten dreams. Tonight's blend is Superposition Censure, a name that's almost as hard to say as it is to explain. The label promises notes of contradiction with a lingering uncertainty. I suspect the marketing department spent a weekend with Schrödinger and never quite recovered. Speaking of which, superposition, that most notorious of quantum quirks, must be given its due. If you've ever wondered how a thing can be both this and that, cat and not cat, biscuit and not biscuit, awake and asleep, you're already halfway to understanding the quantum world. In superposition, a particle does not choose a state until you ask it politely, and, in practice, with a blinding array of lasers and mirrors. Until you look, it's both, neither, something entirely new. To be or not to be wasn't just Hamlet's question. It was the first quantum experiment, conducted with far more drama than most physicists can muster. Pig, as it happens, is no stranger to the art of superposition. There are evenings, as tonight for example, when he seems to occupy two states at once, simultaneously sprawled on the rug and somehow just visible atop the bookshelf, tail swishing in the shadows. I've checked for mirrors, trapdoors and duplicates. None explain the phenomenon. If I attempt to entice him with the rattle of a treat tin, I find him both deeply asleep and suspiciously alert. Approach from the left and he blinks from the right. It's as if, until I lay eyes squarely upon him, he refuses to collapse into a single cat. And just as superposition invites us to accept the impossible, so too does quantum entanglement demand that we abandon the last shreds of classical comfort. The experiments, by now legendary, were conducted with pairs of photons, tiny packets of light born together, then sent their separate ways, often across city blocks or even mountainsides. In labs from Geneva to Shanghai, researchers beamed entangled photons through fibre optics, around corners, through the air and sometimes, for good measure, into the hearts of deep, dark caverns. The results were always the same. Measure one, and the other responded instantly, no matter the distance. No signals, no wires, no polite exchange of postcards, just an eerie, undeniable coordination. The universe, it seemed, preferred its particles synchronized, like dancers in a routine only they could hear. Skeptics, there are always skeptics, suggested hidden channels, clever cheats, or statistical flukes. Each time the experiments grew more robust, more precise, as if reality itself relished the challenge. One famous experiment involved rapidly changing the settings of detectors while the photons were already in flight. Like challenging a pair of synchronized swimmers to swap routines halfway through their dive, it seemed sure to trip them up. Yet the photons did not falter. Their responses matched perfectly, as if they'd conferred in secret, agreed on a strategy, and laughed gently at the notion of distance. I find a strange comfort in these baffling outcomes. There's a sense that the universe, for all its vastness and mystery, is not a cold, impersonal place, but a realm where relationships, connections, bonds, entanglements matter more than isolation or order. The world is less a machine of gears and levers, more a tapestry of threads, each one tugging on the others, however faintly. Pig, for his part, has now migrated, or perhaps collapsed, from hearth to windowsill. Yet, somehow, he leaves an imprint, an indentation in the rug, a lingering warmth, the faintest suggestion that he's still present, watching from wherever cats go when they seem most absent. I wonder if, at the quantum level, there is some vestigial trace, some tiny entanglement between Pig at rest and Pig on patrol, a connection that endures until the next observation snaps the universe back to its singular self. Let me share a story from my days at Abbey Road Studios. During one particularly chaotic recording session, rumour has it David Bowie was present, though all involved deny it, I managed, quite by accident, to be both in the control room and the corridor at the exact moment Alan Parsons was attempting a double take on a particularly tricky drum fill. When the playback was finished, no one could agree on whether I'd offered helpful advice or simply gotten in the way. For weeks afterwards, I was known as the superposed producer, neither there nor not there, both helpful and a hindrance, depending on whom you asked. Quantum mechanics, it seems, is not confined to the subatomic. It flourishes in the wilds of musical mischief. But back to the laboratory. The most astonishing feature of these quantum experiments is not just the weirdness, but the reliability. Over and over, in city after city, country after country, the results come back the same. Particles entangled in their birth, parted by great distance, forever echoing each other's fate. If you think this is a metaphor for old friends, lost loves, or the mysterious way two scones from the same batch always seem to taste the same, even when baked in different ovens, you're not wrong. There's a peculiar poetry in the idea that the universe is built not from things, but from relationships. That to know a thing is to know how it is connected to everything else, to every possibility, to every choice left unmade. Science at its best is a kind of gentle entanglement. We reach out, we measure, we observe, and in so doing we are ourselves changed. Pig, now comfortably asleep on the armchair, occasionally twitches as if caught in a dream. Perhaps, in the world behind his eyelids, he is both chasing and being chased, both the cat and the shadow, both the observer and the observed. Perhaps in that liminal space between waking and sleep, he understands what so many physicists have failed to grasp, that to be entangled is to be both here and there, both together and apart, both the dreamer and the dream. As the fire dwindles to embers and the rain grows softer, I find myself lingering on the threshold of sleep, caught, if you will, in a superposition of my own. Part of me clings to the study, the warmth of the lamp, the steady breathing of Pig. Another part floats free, wondering what it would be like to send a message across the world and have it answered, instantly, by a friend whose face you can no longer recall. In that gentle, drifting uncertainty, I realise, perhaps it is not the answers that matter, but the questions. Perhaps it is the entanglement itself, the shared curiosity, the not knowing together, that makes the universe so endlessly rich. So, dear listener, as you settle under your own blankets, know that somewhere, Pig and I are likewise entangled with you, connected by story, by wonder, by the gentle pursuit of understanding. The world is strange, yes, but it is also kind, and the more we explore, the more we find that we are never truly alone. Next, we'll see what happens when entanglement stretches not just across space, but across time itself, a phenomenon even Pig, in all his superpositions, might find worthy of a pause. Entangled across time, retrocausality and tea biscuits, It's one thing for the universe to play games with space, linking particles, people, and if you're Pig, the location of every heating vent in the house, no matter how distant. But what if the universe's penchant for mischief doesn't stop at the limits of space? What if it has its paws in the fabric of time as well, tying knots between past and future as deftly as Pig knots himself in a patch of sunbeam and shadow? Settle in, dear listener. This is where quantum entanglement takes a deep, luxurious sip of paradox and stretches out not just across the room, but through the hours themselves. Let's begin with a scenario both familiar and slightly troubling. Picture me, Professor Teabottom, shuffling into the study on a drizzly Tuesday morning. I set about preparing the day's tea, an oolong blend I'd saved for just such a grey, contemplative moment, and, by force of habit, I reach for the biscuit tin. There's a special pleasure in the pairing, the robust comfort of a warm cup and the delicate crumble of a shortbread, just this side of sweet. But on this particular morning a strange thing happens. I open the tin to find, horror of horrors, the biscuits are gone, not a crumb in sight. Only a small indent in the tin's lining, suspiciously paw-shaped, offers any clue. Pig is curled innocently on the window ledge, washing his face with the determined air of one who has definitely not been anywhere near the crime scene. Yet, as the kettle whistles, an odd idea occurs to me. What if, instead of grumbling about my poor planning, or Pig's thieving ways, I could reach backward in time? What if, by sheer quantum willpower, I could entangle my present state with a happier biscuit-laden past? Would the tin fill itself? Would the past Professor Teabottom, standing in this very spot yesterday, feel a mysterious compulsion to leave a treat behind for his future self? It sounds preposterous, but in the world of quantum physics such temporal acrobatics are not entirely out of bounds. Retrocausality, the possibility that an effect might precede its cause, or that the future could in some strange way influence the past, is one of those ideas that delights the poet and infuriates the accountant. Recent experiments, mind you, have found curious evidence that entangled particles can be linked not just across distance, but across time itself. Photons created in the present can be entangled with those created in the past, and measurements made today appear to ripple backward, subtly changing the outcome of choices made yesterday. It's as though the universe, unwilling to confine itself to the usual script, has decided to improvise a bit, weaving threads from future to past with no more effort than Pig weaving between my ankles when there's salmon on offer. I confess, the first time I tried to explain this to Pig, he responded with a sort of heavy, whiskered sigh reserved for only the most willfully obtuse humans. But there's wisdom in his indifference. For cats, time is an elastic thing. A warm patch on the rug, a memory of lunch that lingers long after the bowl is empty, the faint hope that by sitting in a certain spot at a certain hour, a miracle might occur in the form of extra tuna. Cats are, I suspect, natural retrocausalists. For us, though, the idea is deeply unsettling. If the future can influence the past, what becomes of responsibility, of planning, of regret? Could I, by fretting today over the vanished biscuits, send a ripple backward, prompting my past self to hide a treat from Pig? Would every uneaten scone become a message in a bottle, drifting upstream through the currents of time? There are, of course, limits to such speculation. The experiments, as always, are meticulously careful. Fractions of a second, particles shielded from interference, results passed with the solemnity of judges at a cat show. Still, the implications linger. Our actions, it seems, are stitched into a tapestry far broader and stranger than the simple thread of before and after. Let me confess something. I once tried, as an experiment in temporal entanglement, to bake tomorrow's biscuits today. The result was a kitchen full of slightly burnt shortbread, an impatient Pig, and a note to my future self reading, "Nice try, check the timer." If anything, the attempt proved that while you can try to cheat time, you can't cheat Pig, or physics. There's a lesson here, somewhere between the crumbs and the quantum. The past is not as remote as it seems, the future not so unknowable. Every decision, every shared cup of tea, every wayward biscuit is entangled with what has been and what is yet to come. To regret is human, to hope divine, but to accept the entanglement of moments, that is the beginning of wisdom. As I sip my tea and Pig at last curls up at my feet, I find a peculiar comfort in the notion that, perhaps, I am in gentle dialogue not just with you in the present, dear listener, but with all the versions of myself that ever were or ever will be. That every story told, every laugh shared, every regret softened by time is part of the great quantum dance. A biscuit crumbled, a tea poured, a cat purring quietly at the edge of mystery. In the next part of our journey we'll explore quantum teleportation, how, in the strangest twist of all, the universe allows information, if not biscuits, to leap across space with no teapots harmed in the process. Until then, keep an eye on your biscuit tin, and remember, sometimes the future has already left you a treat. Quantum teleportation. No teapots harmed. Teleportation. The word alone conjures up Starship's wizardry and the persistent hope that one might bypass both London traffic and the growing queue at the corner bakery. But let's put down the sci-fi novels for a moment, reluctantly I know, and ask, what does teleportation actually mean in the context of quantum mechanics? And perhaps most importantly for the home audience, can it be used to instantly retrieve the teapot you left in the garden during last night's impromptu celestial observation? Allow me to set the scene. The rain has grown gentler, replaced by the comforting sound of drops ticking on the garden path outside. The fire's warmth fills the study, and Pig, ever vigilant, has chosen a new vantage point atop the piano, far enough away to be mysterious, close enough to dart down should a stray biscuit come his way. Tonight's tea is quantum oolong, fragrant, golden, and according to the label, guaranteed not to tunnel out of your mug. Now, quantum teleportation is a phrase that has been tragically misunderstood, thanks in no small part to generations of gleeful science fiction writers and the odd marketing executive with a love for dramatic adjectives. In reality, quantum teleportation is less a matter of disassembling one's atoms and beaming them across the continent, and more a very clever, almost sneaky way of transferring information. Let's take Pig's favourite cushion as an example. Suppose I wish to teleport this cushion from the study to the kitchen without ever passing it through the intervening hallway, a gauntlet of dust, loose shoelaces, and Jupiter's inexplicably placed tennis balls. In the classical world, this is impossible, unless you possess a very determined cat or an exceptionally strong wind. But in the quantum world, teleportation means something subtler. The transfer of the cushion's quantum state, its exact intricate pattern of squishiness, warmth, and faint aroma of catnip, from one place to another, using a pair of entangled particles as intermediaries. The original cushion is in effect, read here, and an identical version is reconstructed there, all without the cushion itself ever physically travelling between the 2 points. How is this magic accomplished? First, you need a pair of entangled particles, let's call them A in the study, and B in the kitchen. These particles have been prepared in such a way that their properties are inextricably linked, no matter how far apart they may be. Next, you introduce Pig's cushion, particle C, whose quantum state you wish to teleport. With a carefully orchestrated sequence of quantum measurements, and ideally a minimum of cat interference, you entangle C with A, effectively mixing their information. This process is as delicate as balancing a tray of teacups during an earthquake, and, if Pig is in one of his moods, likely to end just as badly. Then, crucially, the results of this measurement are sent, by traditional means, no faster than the post, to the location of particle B. There, using the results, an identical copy of the original quantum state is reconstructed on B. The cushion's essence, if you like, now lives in the kitchen, while its original state has been irrevocably altered in the study. This, dear listener, is quantum teleportation. Not the transportation of matter but of information. Not the transfer of objects, but the faithful recreation of their most fundamental properties. Teapots, biscuits, and, mercifully, cats remain where they are, blissfully unaware of the commotion on the subatomic stage. Pig, having observed the entirety of this explanation with a mixture of boredom and disdain, now stretches and yawns in the universal language of "please teleport a snack directly to my mouth." Sadly for Pig, and for all of us with dreams of effortless delivery, quantum teleportation remains a tool for physicists, and, more recently, quantum computer engineers, not for the transfer of tasty morsels or misplaced car keys. It is, however, a glimpse into the future. Already, laboratories around the world have used quantum teleportation to send information across tiny chips, down fibre optic cables, and even, on one memorable occasion, between islands. Each new experiment is a reminder that the universe is far stranger, and occasionally more generous than we could have ever imagined. For the romantic among us, there's a certain poetry in this process. To teleport a quantum state is to trust that the universe, for all its reticence, allows for perfect replication, connection without movement, reunion without travel. It's a dance of probabilities, a gentle handshake across the void. Let me tell you, though, that even in this world of extraordinary science, the most remarkable teleportations still occur in the everyday. The way a story travels from one heart to another, the way Pig, moments ago asleep in the study, now materialises in the kitchen doorway at the softest crinkle of a cheese wrapper, the way memories resurface from the past, whole and gleaming to illuminate the present. If that isn't teleportation of the soul, I don't know what is. So, as Pig returns to his vigil and the fire fades to embers, remember, the universe is full of wonders, both scientific and simple. Quantum teleportation might not help you fetch a teapot from the garden, or save you from an empty biscuit tin, but it does remind us that even across the greatest divides there are ways to bridge the gap. Sometimes, all it takes is a shared entanglement, a leap of imagination, and the willingness to believe that nothing, not even space, can keep us apart for long. In our next instalment, we'll turn from teleportation to the practical magic of quantum computers and cryptography, and imagine what mischief Pig could get up to with a quantum tea brewer. Until then, keep your teapots close and your cushions freshly fluffed. The universe, after all, is always listening. Practical uses: quantum computers and cryptography. There's a long tradition among scientists, myself included, of waxing lyrical about mysteries and marvels, then sheepishly admitting that, when it comes to turning quantum oddities into household convenience, progress is measured in teaspoons rather than leaps. But tonight, with rain pattering steady on the window panes and Pig nestled like a furry comma at the edge of my notes, let's give credit where it's due. Quantum entanglement, once the province of late-night arguments and nervous blackboard sketches, is quietly slipping its way into practical reality. Let's start with the flashiest promise of them all, the quantum computer. Now, the ordinary computers you and I rely on, those blinking rectangles that so frequently offer updates at the worst possible moment, work with bits, the humble 0 and 1. Classical computers are at heart glorified abacuses, sorting and stacking these bits at blinding speed to calculate everything from your shopping list to the latest cat video statistics. Quantum computers, on the other hand, are an entirely different animal. Instead of bits, they use qubits, quantum bits, that can be 0, 1, or, by the mysterious grace of superposition, both at once. It's as though Pig could be simultaneously on the windowsill, under the table, and halfway up the curtain. A scenario all too familiar to those of us who've lived with a determined cat and a particularly elusive spider. But the real magic begins when qubits are entangled. Suddenly information is not confined to neat rows and columns, but weaves itself into patterns that defy straightforward description. Entangled qubits know about each other instantly, no matter how far apart they're separated on the silicon lattice. The result? Problems that would take ordinary computers centuries to solve could, in theory, be cracked by a quantum computer in the time it takes Pig to steal a sandwich and convincingly feign innocence. I see Pig now, twitching in his sleep, perhaps dreaming of a world in which the red dot from the laser pointer can be simultaneously in every room at once. He would approve of such computational chaos. Quantum computers are already making their hesitant debut in laboratories and tech companies across the world. The results so far are modest but promising. Tiny calculations, early successes in optimization, the occasional breakthrough in chemical modelling. It's not the flying car or the self-cleaning litter box we were promised, but it's a start. For now, the quantum computer remains a curiosity, an almost mythical device humming quietly in refrigerated rooms, waiting for the world to catch up. But the quantum revolution doesn't stop at calculation. In the shadows, a second, quieter revolution is brewing: quantum cryptography. If quantum computing is the promise of speed, quantum cryptography is the promise of secrecy, a way to send messages so secure not even the universe itself can eavesdrop without leaving a trace. Here's the trick. Using entangled particles, two people, let's call them Alice and Bob, as is the custom in physics, can generate a secret key, a sequence of random bits known only to them. If anyone, even a shadowy third party with more curiosity than manners, tries to intercept the key, the laws of quantum mechanics guarantee their presence will be detected. The act of observing the particles changes their state, a quantum tattletale embedded in every photon. Eavesdroppers, in this new world, are as doomed as Pig is when caught mid-theft with a biscuit between his teeth. Quantum cryptography is already being tested for financial transactions and diplomatic cables. There are even whispers of quantum-secured video calls, though I suspect the only practical result so far is that no one will be able to hack into your family's annual Christmas sing-along. It's a brave new world, a world in which privacy is, once again, possible, even in the face of infinite curiosity. Of course, not every practical application need be so grand. I once dreamed, after a particularly experimental blend of Darjeeling and ginger root, of a quantum tea brewer. Imagine it, a device that could sample every possible temperature and steeping time at once, delivering through the mysterious process of quantum selection the perfect cup every single time. It would be, I suspect, Pig's second favourite invention after the self-replenishing food bowl. But, as is often the case with new technology, every solution arrives with a rucksack full of new questions. Quantum computers, for all their promise, threaten to upend the world of encryption. Codes that would take today's computers millions of years to crack could, theoretically, be solved in moments by their quantum cousins. The arms race between code makers and code breakers continues, each armed with ever stranger tools, each trying to stay one step ahead of the inevitable breakthrough. Pig, now curled more tightly than the question marks on my page, is blissfully unconcerned with the future of cryptography. His secrets, buried in the garden, hidden behind the bookshelf, woven into the threads of my favourite armchair, are safe for now from even the cleverest quantum spy. And perhaps that is the true promise of quantum entanglement, not just faster computers or safer secrets, but the assurance that, in a world growing ever more connected, there are still places to hide, mysteries to uncover, and cosy corners where a cat can nap, unworried by the peculiarities of subatomic reality. As the rain softens and the fire settles into a friendly glow, I look forward to the day when quantum technology brings more delight than anxiety, more wonder than worry. Until then, Pig and I will continue our experiments with the quantum brewer. So far, all results point to inconclusive but promising, and our explorations of the entangled world. Next, we'll leave behind the circuits and ciphers and step into nature's own quantum workshop, exploring how the birds themselves may use entanglement to chart their journeys across the skies. For now, top up your tea, scratch your favourite cat behind the ears, and let the cosy strangeness of quantum technology lull you gently toward dreams. Quantum biology. Birds that see quantum connections. There's a grand tradition among humans of assuming that the wildest, cleverest inventions must be our own. We devise quantum computers, cryptographic keys, and laboratory experiments, then lean back, rather pleased with ourselves, as if we've wrangled the universe into something wholly new. And yet, time and again, nature arrives with a gentle reminder. That's lovely, dear, but I've been doing it for ages. Consider the migratory bird. Every spring and autumn, flocks of them sweep across continents and oceans, travelling thousands of miles with nothing but wings, a stubborn sense of purpose, and brains no larger than a walnut. These feathered navigators don't consult Google Maps, or even the stars, at least not exclusively. Instead, some scientists believe they tune into the subtlest signals of all, those born from quantum entanglement itself. Yes, dear listener, it seems that nature may have gotten to quantum mechanics before we did, by several million years, and without a single PowerPoint slide. Let's set the scene. It's late autumn in Sussex, the sky thick with grey, and Pig has positioned himself at the window, nose pressed to the cold glass, watching a flurry of starlings wheel and dip through the drizzle. Their coordination is mesmerising, a ballet of wings and whispers, as if each bird shares a secret with its neighbours, a secret as ancient as time. The current best guess among those who study such things is that certain birds possess a remarkable sense known as magnetoreception, the ability to detect the Earth's magnetic field, like a living compass needle. For years this was chalked up to bits of iron in their beaks or heads, a perfectly respectable old-fashioned explanation. But, as with all things in quantum physics, the story soon grew weirder. Recent experiments point to a protein in birds' eyes called cryptochrome, which seems to be involved in this mysterious sense. When light hits this protein, it creates a pair of electrons, born together, just like our old friends the entangled particles, each with its own spin. Here's where it gets delightful. The spins of these electrons are entangled, and their behaviour is exquisitely sensitive to the faintest changes in magnetic fields. In essence, the bird sees the magnetic landscape not with a map or a compass, but with a kind of quantum vision, a ghostly overlay that guides it unerringly from one end of the world to the other. I can't help but marvel at the elegance of it. Nature, in her quiet way, built a quantum sensor and gave it to robins, warblers, and perhaps the starlings that Pig now watches with such intensity. It's as if she whispered, "Here, try this for your next migration. Just don't tell the physicists or they'll want to patent it." Pig, meanwhile, is having his own quantum moment. He seems simultaneously fascinated and indifferent, as only a cat can be, Schrödinger's observer in a warm patch of sunlight. For all I know, he too is entangled with the starlings, his feline awareness stretching just far enough to ponder whether they too dream of afternoon naps and extra treats. It's a humbling thought, isn't it? That the universe's deepest strangeness might be woven not only into our laboratories and blackboards, but into the feathers of a robin, the shimmer of a butterfly's wing, the roots of a tree. Some theorists even suggest that photosynthesis, the process by which plants turn sunlight into sugar, exploits quantum coherence, energy flowing through leaf and cell like a carefully choreographed ballet, always taking the most efficient path, as if the plant itself remembers every possibility at once. If all this seems like the stuff of fantasy, you're in good company. When I first read the papers, I suspected a misplaced April Fool's joke, perhaps the work of a mischievous postdoc with too much time and too little sleep. But the evidence, growing year by year, suggests otherwise. Birds really might see the invisible, guided by the invisible hand of quantum entanglement. Of course, Pig claims to have been using quantum effects for years. How else to explain his uncanny ability to locate the only patch of sunlight on a rainy day, or to appear in precisely the right spot when the cheese wrapper is opened, no matter how quietly? Some nights, I suspect he is everywhere at once, an entangled observer collapsed into reality only when I happen to glance his way. Perhaps there is a lesson in this, one that transcends both feather and fur. The greatest mysteries are not always hidden in the distant reaches of space, or the abstract symbols of mathematics, but in the living world all around us. Nature is, as ever, our most creative and surprising teacher. As dusk settles and the last of the starlings vanish into the hedge, I top up my cup and scratch Pig behind the ears. He purrs, a contented, entangled sound that seems to echo somewhere between here and wherever cats go when they dream. I imagine for a moment that we too are part of nature's great experiment, linked in ways we barely understand, navigating not by compass or calculation, but by the gentle, inexplicable tug of connection. So, as you drift towards sleep, let the wisdom of the birds and the calm assurance of Pig remind you. The universe is always more marvellous than it seems, and should you ever find yourself lost, whether in thought in the woods or in the bewildering thickets of quantum theory, look to nature. She's been solving impossible problems since before breakfast. Next, we'll wander even deeper into the tapestry of reality itself and ask, what does quantum entanglement reveal about the very fabric of the universe? Until then, may your migrations be swift, your dreams be quantum, and your favourite biscuit always within reach. Entanglement and the fabric of reality. There comes a point in every scientific adventure, and if we're lucky every evening storytelling, when the facts run out, the experiments fade into memory, and we're left sitting in the golden glow of what we almost understand. Tonight, as the rain softens to a hush and the logs in the fireplace settle with a final sleepy sigh, I find myself standing at the edge of such a moment, tea in hand, Pig snoring gently on the old tartan blanket by my feet. Entanglement, up to this point, has been a tale of particles, photons, scientists with ruffled hair, and cats with inscrutable motives. But now, as we press our noses up against the frosted glass of the unknown, the question lingers. What does all this cosmic clinginess mean for the very fabric of reality? Are we living in a universe of things, or a universe of connections, a grand tapestry, each thread tugged and teased by every other? It's a notion that would have delighted my old friend Richard Feynman, who loved nothing more than a problem that led, inexorably, into philosophy. The first principle, he used to say, is that you must not fool yourself, and you are the easiest person to fool. Entanglement, I suspect, is the universe's way of keeping us honest. Just when we're sure we've mapped every corner, measured every variable, there it is again. A particle here, a particle there, and yet, no matter how far apart, behaving as if they share a secret. Let's take a metaphorical stroll through the professor's attic, a place cluttered with memories, broken clocks, and, if Pig's hunting is to be believed, the occasional missing sock. Imagine for a moment that every item in the attic, every old photograph, dusty trophy and dog-eared letter is not simply lying alone but invisibly linked to every other. Move one and another shifts, dust off a childhood drawing, and somewhere a forgotten tune on the piano resonates just a bit sweeter. Entanglement suggests that reality is built less like a box of marbles, each neatly separated, rolling about according to its own whims, and more like a patchwork quilt. Each square is unique, but the seams, the stitches, the places where the fabric pulls tight or bunches up are where the real magic lies. When physicists say non-local, what they mean is that our universe is less a matter of distances and more a matter of relationships. An action here is felt there, not because something travelled between, but because, at the deepest level, they were never truly apart. This idea has sent more than one philosopher spiralling off into poetic abstraction, and more than one physicist running for a stiff drink. Yet the mathematics, stubborn as ever, holds true. The fabric of reality is woven from connections, not from isolated parts. To understand one thread, you must, in a sense, acknowledge all the others. Pig, by now, has shifted positions and is draped languidly across two cushions at once, a living embodiment of superposition, if ever there was one. I sometimes wonder if he feels the pull of the rest of the universe, the faint feline tug of distant starcats, or the subtle vibration of the Milky Way spinning through the night. Philosophers have a word for this sort of thinking: holism. The whole is greater than the sum of its parts, and the meaning, the pattern, the reality of a thing emerges not from the pieces, but from the way they fit together. It's as if the universe is less like a bookshelf and more like a symphony, each instrument playing its own line, but the music, the meaning, is found only when all are heard together. There are practical implications too. Quantum entanglement now underpins some of the world's most precise measurements, from atomic clocks to the navigation systems that guide our ships and satellites. When you check the time on your phone or navigate your way home, you are, in a very real sense, leaning on the strange entangled heartbeat of the cosmos. Yet for all the technology, the mathematics, the late-night arguments, what entanglement truly offers is a gentle, persistent reminder. Nothing stands alone. Every story, every cup of tea, every sleepy cat on a rainy night is a part of a greater whole. We are all of us stitched into the same universal fabric, woven from light and dust and curiosity. It's a thought that comforts me, especially on evenings like this, when the wind sighs through the old stone walls and Pig's whiskers twitch with dreams of distant fields. To be entangled is to be a part of something larger, something that stretches out beyond sight or knowing, linking each of us in ways we can barely imagine. And so, as you finish your tea and prepare to drift towards sleep, take comfort in your own connections, the people you love, the memories you cherish, the little routines that anchor your days. In the language of quantum mechanics, you are never truly alone. The universe itself is slightly clingy, a fact that might be its most beautiful secret. Next, we'll let our imaginations roam even further and ask, what if the entire cosmos is entangled? A single, cosmic conversation humming quietly beneath the stars. But for now, let the warmth of the fire and the gentle purr of Pig remind you that the greatest mysteries are often the simplest ones. We are here, together, woven into the fabric of reality, and that is more than enough. Could the entire universe be entangled? There's a particular hush that settles over a house when the rain has finally spent itself. The world outside the window seems to exhale, gutters gurgle their last, and the wind shifts from howling to something like a lullaby. On nights like this, I always feel the universe lean in a bit closer, as if it too wants to hear the end of the story. Pig, meanwhile, having exhausted himself in pursuit of a moth, or perhaps a patch of sunlight remembered from an earlier season, is stretched out across the back of the sofa, his paws twitching in a dream of impossible leaps. It's in this quiet that one of the strangest, boldest questions of all begins to whisper. What if quantum entanglement isn't merely a party trick reserved for photons, electrons, and the odd biscuit? What if, in fact, the entire universe is entangled? A single, boundless conversation in which every atom, every star, every sleepy cat and teacup shares in the same cosmic story. This idea, dear listener, is no mere poetic fancy. In the earliest moments after the Big Bang, the universe was, by all accounts, a much smaller and more crowded place. Every particle now scattered across the billions of light years was, for an instant, part of a singular, seething whole. If quantum entanglement can occur whenever particles share a history, a moment of closeness, an event in common, then surely the universe's birth itself would have left behind a tangle of connections reaching across all of space and time. Physicists have pondered this possibility with equal parts awe and exasperation. Some have wondered whether distant galaxies, separated by unfathomable stretches of empty space, might still be bound by quantum threads, secret correspondences, subtle harmonies, echoes of a time when everything was joined in the tightest embrace. Others imagine that the universe itself is a kind of cosmic orchestra, every note resonating with every other, the music of reality shaped by entanglement stretching from here to Andromeda and beyond. It's a humbling notion, one that puts our everyday worries into cosmic perspective. The lost keys, the missing sock, the mysterious disappearance of a favourite biscuit, which Pig still denies, all become small footnotes in a much grander ledger. For if the universe itself is entangled, then we too are woven into a story vaster than anything we can measure or name. Let's follow this idea a little further. There's a branch of theoretical physics that treats the very fabric of space-time, the stage upon which every cosmic drama unfolds, as being constructed from quantum entanglement itself. According to this view, the distance between two places is not some immutable fact, but the result of how closely entangled they are. The universe is, in essence, not a map of empty space dotted with things, but a vast web whose every intersection, every relationship determines what is near, what is far, and what is possible. Imagine for a moment that you could pluck one strand of this web, a gentle tug on a childhood memory, a longing for a friend seen only in dreams, and across the universe another strand would shiver in sympathy. Perhaps that is why the smell of rain on warm pavement carries us so quickly back in time, or why a certain melody can make us ache for places we've never been. Entanglement is not just a feature of physics, but a metaphor for the ways in which we are all, always, in conversation with the whole. Pig, who has now rolled over and is displaying an unconscionable amount of belly, seems untroubled by such grand questions. Yet I like to think that he too senses the threads that connect us all. There are moments when he sits by the window, eyes wide, watching the clouds scud past the moon, and I swear he is listening to something older and deeper than any human tongue. Of course, the notion of universal entanglement raises its own peculiar puzzles. If everything is connected, how do we ever manage to feel alone? If every atom in my old kettle shares a history with the stars, why do I still burn my thumb on the handle? The universe, it seems, is as committed to paradox as it is to unity. But perhaps that's the lesson in the end. To be part of a universal entanglement is not to be always and perfectly in harmony, but to be engaged in a conversation that never ends, a constant give and take, a dance of closeness and separation, forgetting and remembering. The connections are real, but they are not always visible. The threads are strong, but sometimes tangled. The music is sweet, but sometimes hard to hear through the crackle of static and rain. I find comfort in that. The universe, for all its grandeur, is not so different from a cosy study on a quiet night, full of hidden connections, old stories, and the gentle presence of those we love, whether they are curled at our feet or spinning through distant galaxies. As the embers in the grate glow softly and Pig begins to purr in his sleep, I think about all the threads, scientific, personal, cosmic, that have woven tonight's story. Perhaps, in some mysterious way, telling it has brought us all a little closer, if only for an hour. Perhaps the act of wondering is itself a kind of entanglement, a way of reaching out across the dark, across the years, to say, I am here, and so are you. Next, we'll try our hand at a proper thought experiment. What happens when you put quantum entanglement and teapots together? Pig will, as always, provide a sceptical commentary, but for now, rest easy in the knowledge that whatever the scale, from the smallest particle to the farthest star, the universe is, and always will be, a little bit clingy. The quantum teapot thought experiment. If there's one thing that unites quantum physicists and English eccentrics, it's a fondness for thought experiments. Those whimsical what-ifs that let us explore the impossible without the fuss of equipment, funding, or, for that matter, pants. The most famous of these is, of course, Schrödinger's cat, a hapless feline caught between life and death, depending on the whims of probability and the questionable ethics of Austrian physicists. But tonight, I propose a different sort of mental mischief, a scenario close to my heart and, I suspect, to yours. Settle in, dear listener, and let's embark together on the quantum teapot thought experiment. Imagine, if you will, my battered old teapot. It's a loyal vessel, chipped in 3 places, the lid rattling in a manner that suggests a passing acquaintance with jazz. Pig, for reasons known only to cats and possibly teapots, loves to nap beside it when it's warm, as if soaking up a little residual coziness by osmosis. Now, what happens if, through some improbable quantum event, let's say a power surge, a particularly enthusiastic sneeze, or Jupiter and Jupiter returning home at precisely the wrong moment, this teapot becomes entangled with another teapot, one resting on a distant windowsill in, say, rural Patagonia? The rules of quantum entanglement, mischievous as they are, now apply to these 2 teapots. No matter how far apart, the state of one is inextricably linked to the state of the other. Pour tea into the Sussex pot and the Patagonian pot trembles in anticipation. Place a biscuit on the saucer here, and a corresponding crumb appears, miraculously half a world away. This would, of course, revolutionise both science and international tea parties. Imagine the possibilities. Simultaneous scone summits across hemispheres, instant tea exchanges with friends who've moved to far-off lands, the comfort of knowing that, no matter where you roam, a familiar teapot waits, quietly sharing your every steep and stir. Pig, upon hearing this proposal, rolls his eyes with such conviction that I'm forced to question the wisdom of the entire enterprise. He climbs onto the table, sniffs the old teapot, and gives me a look that says, "Some of us prefer our reality unentangled, thank you very much." But cats are famously conservative about their rituals, and Pig especially so when it comes to the rituals of tea. Nevertheless, the scenario is not as far-fetched as it seems. In the quantum world, entanglement does not care about distance. It does not fade with time or falter with weariness. If 2 objects, however humble, share a quantum history, a moment of creation, a shared experience, they are forever linked. Their fates entwined in ways no ordinary observer can unravel. This leads to all sorts of delightful conundrums. Suppose, for instance, that you break the Sussex teapot's handle. Does the Patagonian handle shiver in sympathy? If Pig bats the lid off my pot, does a distant cat leap from a distant counter, startled by a phantom clatter? If you brew a pot of chamomile here, does the faraway vessel somehow sense the change? Does it too exude the faint aroma of hay and honey? Of course, the limits of this experiment remain firmly in the realm of imagination, and thank goodness, shipping replacement parts across the globe would be a nightmare. But the principle stands. Quantum entanglement is a reminder that even the most ordinary objects, the ones that anchor our days and flavour our stories, are capable of astonishing feats when viewed through the lens of curiosity. It's worth noting that actual quantum entanglement operates on scales much, much smaller than teapots. Think electrons, photons, and the occasional overachieving atom. And yet I sometimes suspect that, if you look closely enough, the whole world is humming with hidden correspondences. The chipped handle of my old teapot may not literally vibrate in sympathy with its Patagonian cousin, but the comfort I draw from it, the memories it stirs, the smile it brings to an old friend's face when they visit, these are their own sort of entanglement, woven not from mathematics but from memory, ritual and love. Pig, for his part, has now lost interest in my philosophical digressions and is kneading the tartan blanket into submission. Yet, as he does so, he pauses and glances at the teapot, as if reconsidering the possibility that some distant feline too is curled up beside a vessel humming with quiet warmth. let me offer a closing twist, worthy of any quantum tale. Perhaps the true magic is not in the teapots themselves, but in the act of sharing. Each time we pour a cup for another, offer a biscuit, or tell a story across time and distance, we entangle ourselves, gently, irrevocably, with the lives of others. Whether by quantum law or human kindness, we become part of a network that stretches from Sussex to Patagonia, from one cosy room to another, from now to all the nows that have ever been. And so, as the evening winds down and Pig at last settles by my side, I raise my cup to you, dear listener. Our teapots may not be literally entangled, but our stories are. In some mysterious, comforting way, your listening shapes my telling, just as Pig's presence shapes the rhythm of my thoughts. Next, we'll return from the world of thought experiments and reflect on the deeper meaning of all this cosmic connectivity, what it reveals about science, about ourselves, and about the endless delight of exploring mysteries together. For now, sleep well, and may your teapot never go missing. Entanglements, mysteries, and our place in them. As the clock slips past midnight and the tea leaves settle in the bottom of my cup, I find myself drawn, as ever, to gentle reflection. Quantum entanglement, for all its technical intricacies and wild implications, ultimately brings us to a place not of cold calculation but of wonder, a wordless awe at how much and how little we truly know. Rain resumes its patter against the windows, and Pig, ever the connoisseur of comfort, circles thrice before settling at my feet, his purr a low, vibrating anchor in the hush of the house. The study smells of old paper and cooling tea, shadows have crept into the corners, yet a warm pool of lamplight holds the centre, like a promise that the darkness is never absolute. For all the time we've spent wandering through quantum paradoxes and experiments, what strikes me now is that science, at its heart, is a profoundly human activity. It's not the numbers or the equations, but the relentless urge to ask, to reach out, to wonder. Why? How? What if? It's the yearning to connect the dots, to peer behind the veil, to refuse to settle for easy answers. In that sense, entanglement is not just a property of electrons and photons, but of all of us. Every discovery in science is born from curiosity, a refusal to let mysteries lie. The ancient astronomer who tracked the wandering stars, the poet who watched the sea and dreamed of distant lands, the physicist who lingered after the lecture to debate, again, the meaning of reality, all are part of this lineage. We're entangled not just with each other, but with all who came before and all who will come after, sharing a conversation that spans centuries. Pig, I am sure, would scoff at such grand notions, but even he is part of this quest. Every time he chases a patch of sunlight, investigates a half-open cupboard, or curls up beside me as I puzzle over a tricky bit of mathematics, he is enacting the essential drama: curiosity, exploration, and eventual contentment. Perhaps that's the deepest entanglement of all, the quiet understanding that, even in our seeking, we belong somewhere. Science, like storytelling, is best when it invites us in, when it says, "Come, let's explore together, let's wonder together." That's why I prefer the company of listeners, real or imagined, to solitary genius. It's why the great debates of Einstein and Bohr were never about victory but about pushing each other, illuminating the darkness with flashes of insight and sometimes laughter. Entanglement is more than mathematics. It is the unspoken agreement that every answer, however tentative, is best shared over tea and biscuits, in a room aglow with possibility. And what of the mysteries that remain? Those questions that even now keep physicists awake and poets dreaming. Will we ever solve quantum mechanics? Will we find a way to teleport ourselves to far-off worlds, or to know, finally, whether the universe is one thing or many, local or non-local, woven from matter or from meaning? Perhaps. Or perhaps the point is not to finish the story, but to keep telling it. To accept that the universe is, in the end, an open-ended conversation. Pig, after all, has no need for closure. He greets each morning with fresh curiosity, each evening with easy trust. The world, to him, is not a puzzle to be solved, but a playground to be explored, a web of sunbeams, smells, and stories. As I gaze into the cooling tea, I think of all those who have shared this journey. Friends old and new, companions in spirit if not in space. Each of you, in listening, becomes part of this entangled web. The words I speak ripple out, uncertain and hopeful, and somewhere in the darkness they are heard, understood, remembered. If I've learned anything from quantum mechanics, it's that the boundaries between self and other, between here and there, between now and then, are softer than we suppose. A story, a glance, a shared laugh can tie us together across years and miles, across the silence that sometimes settles between us. Science is just one way of exploring that truth. Every act of understanding, every spark of recognition is another form of entanglement, a promise that none of us are ever truly alone. So let's hold close the mysteries we have and welcome the ones to come. Let's be grateful for the questions that persist, for the strangeness that endures, for the bonds that quietly sustain us. The universe may be vast and the answers incomplete, but in our wandering, in our gentle, persistent reaching, we find our place. Pig, now softly snoring, has curled himself into a perfect spiral, as if to remind me that every journey circles back to comfort, to companionship, to home. The fire in the grate fades, but a new warmth kindles in the knowing that this night, like every night, is part of something larger, a story we tell together, an entanglement that needs no measurement to be real. And as the final drops of tea grow cold, I am left with this. May our questions be many, our biscuits plentiful, and our entanglements always gentle. Next, a closing thought on why the universe's fondness for clinging is perhaps its most beautiful quality. Until then, sleep well and dream curiously. The universe, slightly clingy but utterly lovely. Night has settled itself decisively over Sussex, the rain now a whispering memory against the garden stones. The house feels smaller, cozier, as if it too has drawn its favourite blanket closer and curled in on itself for a well-earned rest. Pig, untroubled by cosmic mysteries, is asleep at my feet, one paw twitching in dreams of great pursuits, perhaps quantum, perhaps simply after the elusive house spider. There's a peculiar peace in these small hours. The last of the embers glow beneath the grate, casting dancing shadows across shelves lined with books, battered trophies, and of course a teacup or three. I pour myself the final cup of the night and settle into my favourite chair, the one with the odd squeak in the arm and the patch of faded upholstery where Pig has, through the years, established a kingdom. Reflecting on the tale we've shared, I find myself oddly grateful that the universe refuses to keep its distance. Quantum entanglement may sound like a phrase best left to chalkboards and particle accelerators, but in truth, it's as much a story about longing and togetherness as it is about mathematics. The particles, those ever-dutiful actors on the subatomic stage, have shown us that to be alive in this cosmos is to be in some way inescapably connected. To places, to people, to memories, and, if you're very lucky, to the occasional orange and white cat. Perhaps this is the universe's best-kept secret. It clings not out of necessity, but out of a kind of cosmic affection. Entanglement, in all its strangeness, is a promise that nothing ever truly stands alone. Every atom is stitched with the memory of its beginnings, every cup of tea is a reminder of countless hands and histories, every friendship, no matter how scattered in space or time, carries the echo of entangled moments. As I look back over this journey, I'm struck by the quiet persistence of connection. Einstein and Bohr, the biscuits and the teapots, the starlings in their sky-wide murmuration. All these stories are knots in the same great tapestry. Our questions too are entangled. The child's "Why is the sky blue?" is kin to the physicist's "What holds the universe together?" Both are invitations to explore, to reach out, to find a thread and tug it, wondering where it might lead. Pig, waking briefly, stretches and blinks in my direction as if to say, "Don't get sentimental, old man, there's breakfast to consider." Yet even he, with his feline self-possession, is not immune to the gentle gravity of belonging. As he circles my ankles and settles again, his purr weaves its own pattern into the quiet, one more link in the chain of sound and story that makes a house a home. And so, with our quantum tale winding to its end, I'm left with a sense of gentle hope. The mysteries endure. There will always be more to ask, more to wonder, more to discover just beyond the edge of certainty. But perhaps that's what keeps the world, and ourselves, so beautifully unfinished. Entanglement, after all, is not a problem to be solved, but a condition to be cherished. In the world outside, the night is deepening, stars peeking through the ragged clouds. Somewhere a fox barks and the universe spins serenely on, each particle in its dance, each story still unfolding. I like to think that, in some ineffable way, you and I are joined by this little ritual of listening and telling, by the shared curiosity that brought you here, and the quiet faith that there's always another story waiting in the wings. Perhaps, in the end, that's the greatest entanglement of all, the shared promise that whatever tomorrow brings, we'll greet it with wonder, and, where possible, with tea. Pig sighs, his paws curled in perfect contentment. I take a final sip, the last of the warmth lingering in the china and the air. The questions will wait for morning. The answers, if they come, will be all the sweeter for the waiting. Thank you for sharing this journey. Through quantum mysteries and midnight musings, through laughter, stories, and the sweet company of cats. Wherever you find yourself tonight, know that you are a part of something vast and beautiful and gently, joyfully connected. And as always, mind the damp, bring a biscuit, and never ever try to outstare a puffin. And so, dear listener, as the last of the teacups cools and Pig begins to snore most contentedly on the windowsill, we come to the end of tonight's tale. If you've enjoyed this little ramble through the improbable and the quietly profound, do be a dear and like the episode and subscribe to the channel. It helps keep the tea flowing, the lights low, and the cats, both remembered and yet to be, well fed and purring. And don't forget, you're warmly invited to join our free Substack. It's where you'll hear about each new episode as it arrives, and where our growing circle of sleepy science enthusiasts gathers to swap thoughts, dream up topics, and gently bicker about whether Pluto should bring a casserole to the next planetary reunion. Now, one last thing. Tonight's story has been for entertainment purposes only. It is not, strictly speaking, fact. Nor is it entirely fiction. Rather, it exists in that peculiar quantum superposition of the two, until observed, preferably over a cup of something warm. Sleep well, and until next time, may your teacup never be empty.